Hi guys and welcome, Mr. Mustafa here. In this video we are solving part 3 of the June 2021 supplementary examination paper, and we are in the trigonometry section, so please see link for more details. Right, so we are doing the trigonometry, which is in So I've done this in 4 parts. The first one was statistics, second one was analytical geometry. Some nice questions in analytical geometry towards the end, very difficult. And now we are doing trigonometry, which is part 3, and the final part, which will be Euclidean geometry. So let us get straight into the trigonometry. So question 5, simplify the expression to a single trigonometric term. So 5.1, as we can see, a tan of negative x is basically a negative angle, so we can write that as negative tan x, right? Then cos of x remains as cos of x, right? Sine of x minus 180, sine of x minus 180, you can use negative angles there and take out a negative, so it becomes negative sine 180 minus x. Okay, negative sine 180 minus x, and then minus 1 at the end. So now what we have over here is negative tan x is negative sine x over cos x times cos x times negative sine of 180 minus x is just sine x, and then we have minus 1. We can see we have cos x cancelling out, and then we have a negative sine x and a negative sine x becoming positive sine squared x. So it is sine squared x minus 1. Remember, 1 minus sine squared is cos squared, so sine squared x minus 1 is negative cos squared x. So we have simplified to a single trigonometric ratio. Just double checking the answer. It was tan of negative x, which becomes negative tan x, then cos x, that's right, and then if you take doing the negative angle, so negative on the outside, x 180 minus x, second quadrant, so negative sine x, then we have the minus 1 as it is, so negatives, the cos's cancel out, the negatives cancel out, sine squared x minus 1, which is cos squared x, identity. Perfect. Let's look at question 5.2. Cos of 35 degrees is equal to m. Now without using a calculator, so we need to draw a triangle here. So 5.2, cos of 35 degrees is equal to m. 35 degrees here. Let's draw a proper triangle with all these angles and stuff. Right, and let's fill in the triangle. So what we have is 35 degrees here, cos of 35, so on the top we should have 55 degrees. 55, 60, that should give us 90, and cos of 35 degrees is equal to m over 1, so adjacent over hypotenuse, so the opposite is 1 minus m squared. Square root of 1 squared is 1 minus m squared. So 5.2.1, we want to calculate now cos of 215, cos of 215 degrees. Cos of 215 degrees is in the third quadrant. It is greater than 180, less than 270, so negative cos, that should become negative cos 35, because 180 plus 35 will give you 215. Now this will simplify to negative cos 35 is negative m, cos of 35 is m. Then 5.2.2, sine 20, 5.2.2, what is sine of 20 degrees? Now how we can get 20 degrees from this triangle is by subtracting those two. So we can say sine of 55 minus 35 degrees. So this becomes a compound angle, sine cos, cos sine, sine 55, cos 35 minus cos 55 sine of 35 degrees. Now if we solve this, what is sine of 55? Sine of 55 is opposite of a hypotenuse, which is m over 1. What's cos of 35? Cos of 35 is adjacent of hypotenuse, which is also m, minus cos of 55. Cos of 55 is adjacent of hypotenuse, the square root of 1 minus m squared, and sine of 35 is opposite of hypotenuse, square root of 1 minus m squared, which is now equal to m squared minus, if you multiply those two out, you just get 1 minus m squared. So what do we get? We get m squared minus 1 plus m squared, which is basically equal to 2m squared minus 1. Yes, so we are getting 2m squared minus 1. Then 5.3. Determine the general solution of cos 4x plus cos x, cos 4x, cos x, sin x times sin 4x. So we got cos, sin, sin. So this is just cos of 4x minus x is equal to negative 0,7. So what we're getting is cos 3x is equal to negative 0,7. Remember, this was a compound angles. Cos, sin, sin is cos of a minus b. So we can say ref angle, reference angle is cos inverse. Remember, a reference angle is 3x, so a reference angle is equal to cos inverse 0,7. So if we do cos inverse 0.7, shift cos 0.7, I'm getting an answer of 45,57 degrees. 45,57 degrees. Now, where is cos negative? Second and third quadrant. So quadrant 2 solution will be 3x is equal to 180 minus 45. 180 minus 45,57 degrees plus k 360 or 360 degrees times k. Therefore, x is equal to 180 minus 45.57 divided by 3. So you can say 180 minus 45.57 over 3 is equal to 44.81 degrees plus 120 degrees times k, where k is an element of integers. Or where's the other solution? In the third quadrant. So quadrant 3 solution is 3x. Why are we taking second and third quadrant? Because that's where cos is negative. And 3x is equal to 180 plus 45,57 degrees plus 360 degrees k. So we should get another general solution for x, which is just adding here 180 plus, so we are getting 75.19 degrees plus 120 degrees k. So these are my two general solution, one here and one there. Right, so sorted out. 5.4. In 5.4 we want to prove this identity here. So just wait a second, I just want to copy it and come back to you. Okay, welcome back guys. So I just copied this question 5.4 from here to here. Right, so I don't want to waste your time looking at my screen. So what we can say here is left hand side of the equation is now equal to, we got sine 4x cos 2x minus 2 cos 4x sin x and cos x. So we just want to see what we can take out as a common factor first. So we can see we have cos 2x sin 4x. It's for 4 marks. So we have a double angle over here, right? and we got sine x cos x. Alright, so what we can see here, don't try to simplify this. We got sine x cos x, so let's look for a pattern in this one now. So we got 2 sine x cos x, so let's shrink that, make it smaller. So we got sine 4x cos 2x minus cos 4x, and then 2 sine x cos x becomes sine 2x, right, divided by tan 2x, which is now equal to, so usually when I have tan in the denominator, I rather write it as over 1 divided by tan 2x, right, like that. Now let's see what we have here is we have sine cos cos sine, so that's clearly an expansion for sine. So we got sine 4x minus sine 4x minus 2x, and we're dividing it by tan, so we divided by sine 2x over cos 2x, right. So now what we have here is sine 2x times cos 2x over sine 2x. So what we can clearly see is that sine 2x and sine 2x cancel out, and all we are left with is cos 2x, and cos 2x, the expansion for cos 2x is cos squared x minus sine squared x, and that should be equal to RHS. So hence it is proved, right? So that's 18 marks. So basics, obviously simplification from grade 11, then triangles, some grade 11 reduction there, then we have a compound angle, general solution, obviously compound angle general solution is grade 12 work, and then grade 12 work there as well, right? So some nice mixture of questions there. Now question 6 is on trigonometric functions, as we can see here, right? In the diagram below, the graph of f, which is cos 2x. Now the good thing about this is that the functions are given, which means we don't need to solve anything here. Cos 2x, the period of the graph is usually the period of the original cos graph is 360. Since it's 2x, it's now going to be 180. It's a cos graph, the general cos graph, so it's passing through 1 definitely, and the amplitudes are 1 and minus 1. That's perfect. And g of x is equal to negative sine x. G of x is equal to negative sine x. That's the reflected sine graph, and it's normal. We can see the period is this 360 degrees, and the period for cos graph is just 180. We can see one wave here, quarter, half, and quarter. Perfect. It looks like both these graphs are intersecting at a certain point. We can just look at this sine graph. So midpoint in between those two, that's 90 degrees, and we can see negative sine of 90 is minus 1. That is correct. Sine of 90 is 1 and negative 1. So there's a point of intersection there. We can similarly do the same over here, right? You can see there's minus 90 here as well, right? And yeah, so everything is done, and both the amplitudes of both the functions are 1 and minus 1. Without using a calculator, determine the values of x for which cos 2x is equal to negative sine x in the interval minus 180 to 180 degrees. We are both without using a calculator. So basically we need to solve this. Most probably we need to solve this algebraically using general solution. Solving this algebraically, and let's say 6.1. Let's solve this. Maybe we need to use special angles. So what we have is cos 2x is equal to negative sine x. Now to solve this, what we can use is 2 sine squared x minus 1 minus 2 sine squared x. You can convert everything into sine, or you can use cos and sine combination co-ratios. So let us use the double angle and sine, right? So let us use 1 minus 2 sine squared x is equal to negative sine x. Bringing everything over, you got minus 2 sine squared x plus sine x plus 1 is equal to 0. Writing it in standard form quadratic, getting 2 sine squared x minus sine x minus 1 is equal to 0. If we try to simplify this, do we get any answers? Let's see. So we're getting 2 sine x and sine x. We must get 1 and 1. Let's see. So minus here and a plus there. So minus 2 sine x plus sine x should give us minus sine x. Therefore, sine of x is equal to negative half, or sine of x is equal to 1. Now, when is sine x equal to the maximum value? Sine of x is equal to the maximum value at when x is equal to 90 degrees. Yes. When x is equal to 90 degrees, or yeah, if we observe the sine graph, 90, that's from minus 180, so only at 90, because we said only in the interval from minus 180 to 180, so there's only one answer there. And for minus half over here, we can kind of do the reference angle. Sine of x is equal to negative half, so I think sine of negative 30, x is equal to negative 30 degrees, or what about here, which is closer, so 150, sine of 150 will also give you half, or x is equal to negative 150 degrees. So those are the three solutions. Determine the values of x for which cos 2x is equal to negative sine x in the interval from here to there. So sine of negative sine of minus 30 will give us sine 30, which is half, and 2 times 30 is 60, that's also half. What about here? Cos of becomes cos of 300, negative 300, so that's just cos of 300, which is in the fourth quadrant, cos 60, and that becomes, yeah, so we're getting half here. And cos of 180 is, if you're observing the cos graph, cos of 180 should give you minus 1, and sine of 90 is minus sine 90 is also minus 1. So all these three general solution does work. Sorry, not the general solution, all these three values of x are the points of intersection. That's 90, that's minus 30, and that's minus 150, and sorted out. That's done. Use the graphs above to answer the following questions. How many degrees apart are points A and B from each other? Where's points A and B? Points A and B, how many degrees apart are they? They are 120 degrees apart. The distance from minus 150 to 30. Right, so that's 120 degrees apart. 6.2.1. 120 degrees apart. Right, how many degrees apart are points A and B from each other? 120 degrees apart. For which values of x in the interval will f prime x times g prime x? So we are getting derivatives in paper 2, which is good news. So 6.2.2, what does f prime x times g prime x greater than 0 mean? F prime x times g prime x greater than 0 basically means we need both the functions to be increasing simultaneously, increase, or we need decrease and decrease simultaneously. That will give us greater than 0. So where's the function, both functions increasing simultaneously or decreasing simultaneously? We can see from here to that point 0.17. So decrease, increase, no good. That's increase, decrease at 90, decrease, increase, no good. Then what we're looking at here, that's decrease, that's increase. Yes, so we did find, I can find a point here. We can see from here now, from 0 to 90, this function is decreasing and that is decreasing. So 0 to 90, and from 90 to 180, increase. So only from 0 to 90, or so what's the answer? Answer is 0 is less than x is less than 90 degrees, or x is greater than 0, and so you can write it from 0 to 90, or 90 degrees less than x less than 180 degrees. So, or you can write it like this as well: x is an element from 0 degrees to 90 degrees union 90 degrees to 180 degrees. You don't have to put a union there, you can say or. Yeah, we can't include 90 degrees because both of them are equal at that point. They didn't ask for stationary. Increase or decrease simultaneously. There are other techniques. Obviously, if you're doing advanced program mathematics, you can differentiate the trigonometric functions and make it greater than 0. You should end up with the same answer. Determine the values of k for which cos 2x plus 3 is equal to k will have no solution. When will this here have no solution? Right, so let's look at cos 2x plus k, above and below the turning points basically. So let's look at 6.2.3. So cos 2x is equal to k minus 3. Right, so cos 2x will have no solution if it is above, where's the cos graph? Yes, if it is above 1. So we're kind of solving like f of x is equal to L, right? F of x is equal to L. So k minus 3 is like kind of my L factor. So I'm trying to solve for that. So we can say when this is the same thing as saying what is cos 2x? Cos 2x was f of x, yes. So f of x is like equal to L, that's what we're solving for. So when k minus 3 is greater than 1, the value of k minus 3, if k minus 3 is greater than 1, so it's above, it will have no solution, and below as well, or less than minus 1, or k minus 3, or when k minus 3 is less than minus 1. So when k is greater than 4, or when k is less than minus 1 plus 3 is 2. So k greater than 4 or k less than 2. Yes, those are the two solutions. If k minus 1 is greater than if k minus 3 is greater than 1, or if k minus 3 is less than minus 1, below minus 1. Yes, so we have done this correctly. Yes, these are my two solutions, k greater than 4 and k less than 2. If you have any other methods, please don't forget to comment. Right, let's look at the next question, which is question 7. Right, so in question 7, what we have here? Yes, 3D. So we have points B, C, and E lie in the same horizontal plane. B, C, E. ABCD is a rectangular piece of board. ABCD is a rectangular piece of board. So this length is equal to that length, and AB is equal to CD. Correct. So you can see we can transfer the information from CD to AB. Yes, CD is a triangular piece of board having a right angle at C. CDE. CD is a triangular piece of board having a right angle at C. Okay, makes sense. Each piece of board is placed perpendicular to the horizontal plane and joined along CD. So this is perpendicular to the horizontal plane, this is perpendicular. Okay, simple to understand. Joined along CD, so that's where it's joined as shown in the diagram. The angle of elevation from E to D is X. E to D is X, so looking upwards from E to D is X. That's angle of elevation. BEC is 2x, BEC is 2x, and EBC is 30 degrees. Where's the 30 degrees? There's it here, right? Show that CD, so 7.1, we want to show that CD is equal to BC over 4 cos squared x. We want to show that CD, so we're looking at this length CD and BC, that length over here, this length over here, BC. Show that CD is equal to BC over 4 cos squared x. So the most amount of information that we actually have is in this triangle over here, and in this triangle what we can do is we can find EC. If we find EC, then we can get BC in the formula. Yeah, so let's try to find EC from this triangle. In triangle BEC, in triangle BE, right? I like to write down the name of the triangle that I'm working with. In triangle BEC, I can say I want to find EC. So I can say EC over sine 30, right? Because I can see this formula involves BC DC. So I can say EC over, I'm using the sine rule, sine 30, EC over sine 30 is equal to BC over sine 2x. Alright, that's sorted out. Now we can make EC the subject of the formula and take sine 30 across. So we have EC is equal to BC, sine of 30 is half, right, and sine 2x, leave it as sine 2x. So that's what EC is. Now since we have EC, let's try to find DC. So in triangle, in the right angle triangle DEC, I can just apply SOHCAHTOA here because we have a right angle triangle. We can say DC over EC, we can use tan, we can say DC over EC, DC over EC is equal to tan x. Now we have EC already and we got tan x here, so let's try to simplify this. So tan x is sine x over cos x is equal to DC divided by, what is EC? We need to eliminate EC and introduce BC, divided by 1 over 2 sine 2x. So this is basically 1 over 2 sine 2x, and that's BC on top. So kind of saying BC over 2 sine 2x, right? Now we've got sine x over cos x, so leave it as sine x over cos x is equal to DC times 2 sine 2x over BC. So we want CD on this side and take everything over, right? So we want CD on this side, so DC on this side, so I can multiply this with sine x, so sine x times BC all over 2 sine 2x. So we got DC is equal to sine x times BC. I've just cross multiplied, guys, right? So I just took this BC over and I've divided by 2 sine 2x. There's it here, right? Multiplied here and divided by 2 sine 2x, and don't forget the cos x in the denominator as well. The cos x needs to be there, right? Cos x times a cos x. then divided by 2. What is sine 2x? We can open that up. Sine 2x is 2 sine x cos x, and then times a further cos x. So what we can see now is that the sine x and the sine x cancels out, and all we are left with is dc is equal to bc over 2 times 2 is 4, and cos times cos is cos squared x. Right, so that's our solution. So DC, so we kind of found DC in terms of BC or in terms of AD. Now if x is equal to 30 degrees, show that area of ABCD is 3 times AB squared. If x is equal to 30 degrees, now remember, if x is equal to 30 degrees, then we can find CD. So if x is equal to 30 degrees, 7.2, we can find CD, which is equal to BC over 4 cos squared 30. Cos squared 30 degrees, which is equal to BC over cos of 30 is root 3 over 2, so 4 times 3 over 2, so we're getting 6. Just doing it on this calculator, let's see. So 4 times cos of 30 close and squared, we're getting an answer of 3. Wait 1 second, how do we get an answer of 3? So it's basically 4 times cos of 30. What if I do cos of 30? Yeah, so it was root 3 over 2, so it's supposed to be 3 over 4 rather. Yes, so what we're getting is BC over 3. So CD is equal to BC over 3. CD is equal to BC over 3. In other words, if we cross multiply or bring this BC down and take this 1 across, we got CD is to BC is equal to 1 is to 3. That's what we're saying. CD is to BC is 1 is to 3. So CD is to BC is 1 is to 3. CD is to BC is 1 is to 3. Right, so 3 BC will give you 1 CD. Yeah, that's what we're saying. No, not 3 BC. CD is 1. 3 times CD will be here. 3 CD will be here. So BC is equal to thrice CD. Yeah, we should have wrote that down rather. BC is equal to 3 times. This implies BC is equal to 3 times CD. Right. That's what we can write from this conclusion. BC is equal to 3 times CD. Now if you want to calculate the area of ABCD, to calculate the area of ABCD, area of this rectangle is BC times CD. Right, so area is equal to BC times CD, but now BC is already 3 times CD and CD is just CD, so you got 3 CD squared. So that's our final answer. So we are getting the area of the rectangle to be 3 CD squared, but CD is equal to AB. But CD is equal to AB. Opposite sides of, what should we write? Opposite sides of rectangles are equal. Opposite sides of rectangle equal. So which is basically equal to 3 times AB squared. That should be it. Yep. And that brings us to the end of part 3 of the June 2021 supplementary examination paper. I hope you enjoyed this video, guys. Don't forget to share this video, like and subscribe to my YouTube channel. Thank you. Don't forget to see link in description box for part 4, which is on Euclidean geometry. If you want to go to the previous parts, see for link in the description box. Thank you, guys. Hope you enjoyed this video.